Hello, everyone. So really, this is the pinnacle that we've been building towards for quite some time. We're going to be factoring a polynomial completely. So if we notice that this is a fourth degree polynomial, we call this a quartic function, as you'll quickly discover in a couple of days. So this is a quartic function, x to the power of 4. The maximum number of prime factors that this can have is 4. Simply because x, you'll see, you'll see. All right, let's go. Let's take this. So I'm going to factor this. If you recall our numeric example, the first thing that I need to do is I need to find a factor. Uh-oh. So what am I going to do is I'm going to create a list of all possible factors, just like what we did in the previous video. So all possible factors x minus a can be found. Well, I would like you to hit pause and tell me what are the possible values of a for this polynomial. Well, thanks for joining me back. I'm sure that you've hit the unpause button. The values of a that I get are like this. So allow me to work through this. Remember that we have to work through the factors of the constant term. The factors of -6 are positive and -1, positive and -2, positive and -3, positive and -6. Now, the factors of 2, the leading coefficient, are positive -1 and positive and -2. So I can quickly say all the different combinations are 1 divided by 1, which are positive and -1, positive 2, positive 2 divided by 1 is positive and -2, 3 divided by positive and -1 is positive and -3, 6, 1/2, and 3/2. So my purpose isn't today, this is a list. Now I need to find a factor. Now what I'm going to do is I am going to use the factor theorem. So very quickly, I would like us to use the factor theorem. Now remember, we're trying to find f of a is equal to 0. If we can find some constant, whose value when you plug it into the function is 0, you can conclude that you have a factor. So I'm just going to go systematically go through my list. Now, I don't wish to torture people, so generally speaking, these higher numbers and the fractions I won't include. But that's just because I'm being a nice guy. It's not because it's mathematically correct. So please go through this and figure out which factors work. So I think that you're joining us now back. What you'll notice is that the f of 1 will be simply 2, 1 to the power 4 plus 1 to the power 3 minus 4 to the power of 1 squared minus 9 to the power of 1 minus 6. If you calculate this through, what's really important is that the f of 1 does not equal to 0. So what does that mean? It means that x minus 1 is not a factor. So that didn't work. Now that's really unfortunate. Now I'm going to go on to the next factor and the easiest calculation. So I have a list of all my possible. I think that I'm going to choose -1. So the f of -1. And when I put that in here, into my function, I think I've done that correctly. I'm going to evaluate it, press pause, you do the calculation. Welcome back. So hopefully you've discovered the f of -1 is equal to 0. Now this is really, really fundamentally important. So I'm just going to put this blank sheet of paper here. The f of 1 is 0. This is the factor theorem. So we're going to factor this completely. We are going to use the process of factoring, the factor theorem. So we have to use the factor theorem. This is it. And I can conclude now that x minus or x plus 1 is a factor. Now now think back when we had numbers. Now I can start this division. So I'm going to start this division, and very simply, I'm just going to work through this, and since x minus 1 is a factor, what I'm going to do is I'm going to take x plus 1, I'm going to divide it into my polynomial x to the power 4 plus 1 minus 4x minus 9x minus 6. Now, I could long divide that, but I don't like long division. I hope that you've quickly developed a preference for synthetic division. So I'm just going to synthetically divide this. And this is going to seem like magic to you if you've never seen synthetic division. It's so quick. So I'm going to carry down that 2. Negative 1 times 2 is negative 2. 1 plus negative 2 is negative 1. Negative 1 times negative 1 is 1. Now add down, multiply across. Add down, multiply across. Negative 4 plus 1 is negative 3. Negative 3 times negative 1 is 3. I'm getting pretty excited here because negative 9 plus 3 is negative 6. Negative 6 times negative 1 is positive 6. So therefore, oh my God, it has a remainder of 0. Exactly what the factor theorem just said. We're going to have the remainder of 0. So now what we know is that I'm going to work that this is my remainder, this is my constant, this is my coefficient for the x to the power of 1, this is x to the power 2, this is x to the power 3. So that my polynomial f of x was 2x to the power 4 plus 3x minus 4x squared minus 9x minus 6. We now can write it as x plus 1, which was my divisor, goes into this, and the resulting was my quotient was this. So I'm getting pretty close here, I think. I've just knocked this down a degree. So this is f of x. Now I'm going to call this, now it's going to be strange, I'm going to call this a prime factor. There's no two items multiplied together to give me x plus 1. However, there might be other factors of this. So now I'm just going to repeat the whole process for this. What I would like you to do now is to find a factor of this. Press pause, and we will see where you are at. All right, I hope that you're coming back to join me. You've completed the same process for this polynomial. You're trying to find one factor of that. I'm hoping you have concluded that x minus 2 is a factor of 2x cubed minus x squared minus 3x minus 6. So now, since the question dictated that I use, now this is a part of the question, not a part of the reasoning, that I've used the factor theorem, I haven't used long division, I've used synthetic. To be honest with you, if it was up to me, I would use synthetic each and every time. It's so much quicker. However, I'm just going to now divide these two quantities. Please press pause on the video and divide these two quantities. Welcome back. I believe if you divide x minus 2 into this larger polynomial, you should get a quotient of 2x squared plus 3x plus 3. So what have I done? So really, now this is almost over. It seems like it goes on forever, but instead of writing this, instead of writing f of x is equal to x plus 1 times 2x cubed minus x squared minus 3x minus 6, I know I can break this up into two other factors. X minus 2, 2x squared plus 3x plus 3. So my polynomial f of x is factored. And this, we're getting pretty close to the end. Now I need to break up this polynomial. Right now we're at a quadratic. So I challenge you, actually I don't because I'm not torturing you, to factor this. Fact is, you cannot factor this. This is an unfactorable quadratic. So this is our polynomial that is totally factored. I hope this went well. How do you know that this is not factorable? Because you'll go through all the possible values of a, and none of them you'll have an f of a is equal to 0. You'll find it not a factor. Or a lot of you guys probably are able to look at it and being like, nope, that is not factorable. Also, closely related to this is you may want to throw these values into the discriminant. What you'll see is that the discriminant, it is a non-perfect square. I hope this helped. Good luck. If you have any questions, feel free to ask.